In this lecture, we will learn about the RSA Cipher and how to implement it in Python. The RSA Cipher is a public key encryption technique. It is the most secure type of encryption in all of cryptography. There are two keys, a public key and a private key. Anyone can get someone's public key to send an encrypted message because the public key is public. Only the person getting the message has the private key, which allows them to decrypt it. So the public key is used for encryption, and the private key is used for decryption. Let's take a look at how to implement the RSA Cipher. The first thing we will need to do is use pip to install the PyCryptoDome module. First, we will change directories using the cd command to the folder holding our Python file. Then we will run the following command, pip install PyCryptoDome. When we hit enter, the installation process will begin. Once that finishes, we are ready to jump to PyCharm and start coding. Up at the top of the code, we will type from crypto.publickey import RSA. Then we will type from crypto.cipher import pkcs1 underscore OAEP. Next, we will type from crypto.hash import SHA-256. Finally, we will type from crypto import random. After that, we will create a function responsible for creating a new set of public and private keys. We will name the function newKeys, and it will take in a parameter named keySize. Note when passing values into this function that the key size must be greater than 1024. Inside of this function, we will create a variable named randomGenerator, and set this equal to random.new.read. Then we will create a variable named key that we set equal to rsa.generate and pass in keySize as the first argument, and randomGenerator as the second argument. Next, we will create a variable named private and a variable named public, and set them to key and key.publickey respectively. Finally, we will return public, private. Then we will create a function named encrypt that takes in two parameters, message and public key. Inside of this function, we will create a variable named cipher and set it equal to pkcs1 underscore OAEP.new with public key passed in. Next, we will return cipher.encrypt and pass in message. After that, we will have a function named decrypt that takes in two parameters, ciphertext and private key. Inside of this function, we will create a variable named cipher and set it equal to pkcs1 underscore OAEP.new and pass in private key. Then we will return cipher.decrypt and pass in ciphertext. Then we will create a public key and private key variable respectively, and set them equal to newKeys with 2048 passed in. After that, we will create a variable named message that we set equal to the binary string hello world. After that, we will create a variable named encrypted message and set it equal to a call to the encrypt function with message passed in as the first argument and public key passed in as the second argument. Then we will print out the string encrypted message followed by the encrypted message cast to a string. After that, we will create a variable named decrypted message and set it equal to a call to the decrypt function with encrypted message passed in as the first argument and private key passed in as the second argument. Finally, we will print out decrypted message followed by the decrypted message cast to a string. When we run the code, notice that the message was encrypted using the public key and then properly decrypted thanks to the code that we wrote. In the next lecture, we will look at a recap of what we learned in this section of the course.